All right, guys. Are there any questions from homework stuff first? Nothing? Okay. All right. So here's the plan. All right. We're going to talk about section 13.1 and we'll see how far we get. I want to devote at least Wednesday and Thursday this week to review for the final. We've got the practice final. Some people told me there's some problems I didn't finish on the video, so we can do whatever problems I didn't finish on the video we could do. So Wednesday and Thursday will definitely be wide open. Anything we've discussed this semester can come up. Anything that's bothered you, anything that you're like, I don't have a freaking clue every time you talk about this, what the hell are you talking about, Jeff? Bring it up, maybe in a less confrontational tone, but you know, you can bring it up, we can talk about it. We might start doing it tomorrow. We're probably not going to do all of chapter 13. So I'll let you know exactly what's due and what isn't necessarily due. Very interesting, I know. Okay. So if there's no questions from homework or anything, I think I like this better over here. Let me switch this around. All right, it's driving me crazy. Floating around the mountains. No questions. No questions. No questions. All right, so we're gonna get back into. This is all freaky. Ah, shit. So I don't make all my money on the YouTubes. All right. So if there's no questions, let's do this. Did anyone notice? I think a few people definitely did. Did you guys notice there's some new grade stuff up on Canvas? All right, let me talk about that real quick. So here is a generic student. This is nobody specifically. These three have been up here since the midterm, right? So I just updated those. So those are up to date now. I graded, I should have graded all the quiz corrections, all the midterm corrections. So let me know if that's not true. I'm pretty sure I did. Let me know if that's not true. So those three are the same as they were before, right? Your average grade, not counting homework. If you turn all the homework in, it goes up a little bit. If you haven't turned any homework in, that goes down a bit. And then these two grades, you want them to be low. Yes. This is the grade you need on the final to pass if all your homework is turned in. And here's the grade you need on the final to pass if none of your homework is turned in. Now, I really, really hope that there are people out there that want to do more than just pass. If you want to do more than just pass, here's the thing. If you add 32, so for this person, this student, if they had turned all their homework in, add 32, that's 98. I'd have to get a 98 on the final to make a B minus. If you add another 32 on top of that, it tells you what you need for an A minus. For this student, that is out of touch, out of reach. That's not going to happen unless there's like major corrections they can still do, right? If you did really bad on the midterm and you haven't made corrections, that would be quite a good bump to your grade if you would just do those corrections. The nice thing is with the corrections, quizzes, midterm, it all gets you ready for the final at the same time. You're raising your grade and you're studying for the final. It's almost like I did that on purpose. Motivation to actually study is amazing. I'm trying. All right. Any questions about the grades and how to interpret them? These guys, anything? Have you guys looked at those? All right. I'll take that as that's all good and understood. Okay. So if there's no questions from homework, we're just going to get right into chapter 13. Normally for community college, a C is passing, which is why C minuses don't exist at community college level. They're actually illegal to give a C minus. But a C is considered passing because you need a C for it to transfer to a university or another 4-year college. So that's a good question. All right. Okay. All right, so now let's get into anybody else, anything else before I launch into my chapter 13 spiel. Okay. All right, let me turn off my background. That was Zion National Park, by the way. Let's see. Okay, so we're leaving the last chapter behind. We pretty much finished that out. What did I say? Yeah, ellipses, hyperbolas, parabolas. I try to truncate that homework down from what I would normally give. So it's all from the review section. So it shouldn't be too heinous, I'm hoping. So we're going to find out. You guys got to let me know if you have questions. So we're going to get into something that's going to seem a little bit less intense, which is nice. It's always a welcome change, less intense. We're getting into something called sequences and series. So when I say the word sequence, what comes to mind? Anybody? If I say the word sequence, what comes to mind when I say the word sequence? Not sequins, not like the little things on dresses and stuff. Does anyone have any? Yes?
1, 2, 3.
Beautiful. I love it. There's a beautiful sequence. Sequence of natural numbers. Numbers in a line. Okay, maybe. So a sequence needs to have some defining characteristic. And we've seen very simple examples of this already. So, for example, oops, yeah, there. I see all this, all right? No. Shoot. So there's a very simple, oh yeah, let me make this all about me. I keep forgetting to do that. Boop. Oh, this is weird. All right. Okay. So here's a very simple sequence. Maybe not as simple as 1, 2, 3, but still. What's next in this sequence here?
10.
Yeah, exactly. Well, and there could be other answers, to be honest, that I'm not even thinking about. But of course, what's the defining property of the sequence?
3.
Add 3. I love it. You just keep adding 3. So I add 3. I like it. Now, let me push this a little bit more. So that's a very simple sequence. Let me identify a few things, some terminology, some notation that we use. We call, for example, the first element in a sequence, we call it A1. So amazingly enough, this would be A2. And Jeff, you can do better, my friend. There you go. A3 and so forth. Blah, blah, blah. So what I want to do is I want to get a way to figure out AN quickly. I don't want to have to write every damn element of the sequence. If I wanted to know what A827 is, there has got to be a quick way to do that because there is a pattern that leads me through the sequence of numbers. Can we figure out how to figure out the nth term? So let's kind of break this down a little bit. How did we get to 4 from 1? We obviously added 3. We added 3 once. So now if I start at 1, I can add 3 twice. All right, let me stop for a minute. Nothing amazing here right now. Don't worry if you're bored, if you're like, this is too easy. It's coming. All right, it's gonna get freaky. So can somebody figure out a formula for AN? So this would be like 1 plus 3 times 0, right? So the first number is 1 plus 3 times 0. The second number is 1 plus 3 times 1. Third number is 1 plus 3 times 2. So AN has got to be 1 plus 3 times something. What's the pattern? First element, 0. Second element, 1. Third element, 2. Nth element,
N minus 1.
N minus 1. I like it. Does everybody see that? This specifically, this kind of thing that's based on addition, that's based on addition, is called an arithmetic sequence. It's kind of nice. How important is it for you to know that word? Not crazy important. Okay. Now let's generalize this. Let's try to generalize this. So I'm going to erase all this. You guys ready? I'm going to erase it. Let me kind of capture what we just did. 1, 4, 7, 10, 13, blah, blah, blah. We figured out AN is 1 plus 3 times N minus 1. And of course, some of you guys might realize you can simplify this a little bit. I don't care about that. There we go. I like to see the word Fibonacci. That's awesome. Fibonacci is one of the best sequences. We'll do that in a bit. That sequence is a little bit harder to identify AN for. I'm going to erase all this. I like it. I do it as I say it. That's always a great way to do it. So what about do the same thing we just did, but do it for this sequence instead. What do you got, Jeff? You can do it, buddy. Write something. There it is. There you go. Try to come up with AN. Don't say anything yet. Don't type anything yet. Just try to do it. All right, so somebody tell me what's the basic pattern here. What do I keep doing?
Does it minus 9?
Good. I keep subtracting 9. Thankfully, it looks like I did subtract correctly. That's always nice. So now somebody else tell me. Well, let's see. A1 is 80. A2, I would do 80 minus 9 one time. A3, I would do 80 minus 9 twice, right? So that does come out to be 71. That does come out to be 62. So what is AN? What is AN? Why is it always? Anybody?
80 minus 9 times N minus 1.
Yeah, 80 minus 9 times N minus 1. Exactly. So now look here. So what's the general form of the nth term of a sequence based on addition? Now, does anyone disagree with me that this is based on addition? Somebody probably should. No, you're all cool with that. Why is everybody okay with me saying that's based on addition? Are you guys up? Come on. All right. There is no subtraction. Is everybody okay with me saying that? There's no such thing as subtraction. There isn't. It's a figment of our imagination. No, so subtraction is just adding the additive inverse of something. That's all subtraction is. So subtraction is addition. Whoa, multiplication is multiplying by the inverse. I mean, division is multiplying by the inverse of something. So there is no division, right? There is no spoon. Big or small. So anyway, that's not a big deal. So I keep adding -9. This is an arithmetic sequence because it's based on addition. Any arithmetic sequence. What goes here? What was special about the number 1 or the number 80? What was special with that? Why was that special for these two sequences? This first number here, what's special about it?
Constant.
The first term. So if the general nth term for any arithmetic sequence. Good Lord, Jeff. Oh, it's too many words. AN equals A1 plus, and what's this number here? We're going to give this number a parameter. We're going to give this thing some kind of a symbol. So what I'm going to call it is D, because it's the repeated difference. Right here, it was 4 minus 1 is 3, 7 minus 4 is 3. Here, it's 71 minus 80 is -9, 62 minus 71 is -9. It's the repeated difference. So we're going to call this D. So it's going to be plus D times n minus 1. That's what we kept getting. So this is how to find the nth term of anything based on addition or subtraction, if you want to use that word. You guys with me out there? Was that difficult? Has anyone ever seen that kind of thing? Have you ever seen that before? If I didn't give you this equation, couldn't you have figured out the 870th term here without using this? Yeah, of course you could, but it's nice to have a function that I can just use directly. So what is the, can somebody figure out the 38th term of this sequence? Now it's easy, right? What's the 38th term in that sequence? -253. -2. I'm kind of mumbling the answer, I think, if I did it right in my head. Has anyone got that? The 38th term for this sequence? Nobody? Anybody? Are you guys still watching this channel? Have you switched channels? Is there a better show on Netflix? I'll bet you there probably is. I can't really compete with Netflix. I don't have the kind of budget. Anybody doing that? Anybody? Not yet. I'm sorry.
253.
Great. Okay. So -253. Not that difficult, right? You just gotta throw a 38 into the equation. Do it. You got it. No big deal. And it's got to make sense. If I have a simple sequence based on adding 3, based on subtracting 9, whatever, there should be a simple way to figure out whatever term I want. It has to be, because it's based on something so simple. Okay, so that is how you do anything based on addition or subtraction, right? Okay. Let me erase all this. Let's talk about it. You know, that took us a while to talk about. And that's our first kind of sequence. Does a sequence have to be based on addition? No, of course not. Does a sequence have to be based on this kind of thing where I do something to one term to get the next? No. What about this sequence here? What do you got, Jeff? I wish I knew. It's going to be written down. Here it comes. There it is. Look at that happening. I'll be nice. Some of you guys can see I can be really evil with this one, but I'm not going to be. Am I adding 3/5 plus a number to get 4/6 plus a number to get 5/7? Please tell me the right answer there. Am I adding a number to get from 3/5 to 4/6 to 5/7?
No.
Hell no, right? The correct answer is hell no. I like it. What is 4/6 minus 3/5? That would be, let's see, 1820. It's 230. It's 1/15. So this is like plus 1/15. This is 2830. This is 2. This is 1/21. Oh my God, that's gross, right? No. There's a much simpler answer, isn't there? So this is not based on adding the same number and over, but is this a difficult sequence? Is this a difficult sequence?
No.
Shit, no. What is A1?
3/5.
3/5. A2 is 4/6, which is 3 plus 1/5 plus 1, right? Which is actually, we can break it down even more. Let's not do that. So here's the idea. I want to rewrite things so I capture what's happening as I step through. This is 5/7. So how could I rewrite 3/5 to capture 1, and then 2 makes everything go up by 1? I don't know, you guys. I really want you to get this idea. I'm not sure what that answer is for. Private chatter. All right, let me just show you. Isn't this 1 plus 2 over 1 plus 4, right? I could have written it the other way, but that's all right. You could do it, Jeff. 2 plus 1 over 4 plus 1. All right. And isn't this 2 plus 1 times 2 over 4 plus 1 times 2? Do you see how I'm kind of doing the same thing I was before, just in ratio form? This looks a lot like the one on the practice final exam that was pre-completed. Yeah, okay, yeah, good. So there's a whole section on the practice final that relates to chapter 13 that some people were asking me about, and I'm like, we haven't even talked about that shit yet. And we're talking about it now. I like it. Okay, now, and this would be 2 plus 1 times 3 over 4 plus 1 times 3. So what's AN? Do you see how I discovered 1, 1, 1, 2, 2, 2, 3, 3, 3? So what's AN gonna be? What's always stays the same all the way down? 2 plus 1 times something over 4 plus 1 times something. Right? And of course, what's that something going to be? Yeah, okay. So let's test it out. What would A4 be if I use this form? It would be 2 plus 1 times 4 over 4 plus 1 times 4. A4 would be 6 over 8, which is what it is. So you can see, I could have made this a little harder if I would have reduced these, correct? If I would have given them to you in reduced form, you would have first had to figure out, oh, those have been reduced. I got to build them back up. That's kind of like the next level of this. If you have fractions, maybe some of them are reduced and you can't see the pattern because they're not showing it to you. They've been reduced. Oh, I see what you mean. So again, I understand that sentiment in the chat. I'm not, so here's the thing about sequences. A sequence generates a list of numbers. I am not saying that it is legal to do this. This is not what I'm saying, correct? I'm not saying that 3/5 equals 4/6. Nowhere did I say that until now. And as I was writing it, I was saying I'm not saying that. So even then I wasn't saying it. Is that, do you guys understand? So I understand your point. Is that your point, sort of, Jordan? Yeah, good. So notice I'm definitely not saying that this equals this equals this. This is asking me, how do I go from here to here? Well, I do add one to the top and bottom to get to the next one. That's exactly how this pattern works. So I'm just identifying the pattern. Sometimes this is called number generators. This thing generates a list of numbers as you cycle n through all of its possible values. Does that make it feel better? I understand that feeling, and it's actually good to have a feeling because you know that's bullshit. But that's not this. This is saying I want to generate numbers. I want you to tell me what the machine is that would generate those numbers. I like it. All right. So what about, let's do another one. I'm gonna erase all this. Here we go. Now, I mean, it's very, very easy to create a sequence that it's really, really hard to figure out what the nth term will be. We've done some very simple examples. There's you could take a whole year's worth of study determining all these different ways to figure out sequences from some given number of elements. Let me not try to do that to you right now. Let me try to make one that's not so evil. You can do it, Jeff. I'm not even, let me see. All right, here we go. I got it. All right. Yeah, all right. I like that. That looks gross. I'm gonna let you stare at that for a little bit. Does anyone notice anything? Give me anything about these numbers that you see is kind of common here, in at least in some of them.
Odd.
All right, I like it. They're odd, except 0 isn't really considered odd or even, but I know what you mean.
The number plus the number plus 1.
Oh,
So-
I see what you're doing.
So
Sure.
0
Yeah,
plus
yeah,
0,
yeah.
1.
That's a really interesting way to put it. You've got the answer, but you just said it in a different way, which is not a wrong way at all. So the number plus the number plus 1, the number plus the number plus 1, right? What's 1 plus 1? 2 plus 1 is 3. What's 3 plus 3? 6 plus 1 is 7. Of course, what's another way to say a number plus itself? What's x plus x?
X.
Another way to say a number plus itself is twice the number, right? I like it. But is that going to get us to where we need to be? All right, now, does anyone see something else that's almost, I really need you to understand how that's kind of difficult to do, because that's kind of like capturing how what I'm adding keeps going up. It's not a constant addition, right? I keep adding something more based on what was there before. That is a difficult way to write a sequence. It's not impossible. We're going to talk about, in fact, the Fibonacci sequence, I think we're going to talk about next. Talk about recursive sequences. Try this. Every number is odd. What if you add 1 to every single one of the numbers? What do you get? If I add 1, what do I get? I get 1, 2, 4, 8, 16. Do those look familiar? No, even's not good enough because do I have 6 up there? No. Do I have 10 up there? No. So it's not all even. So saying even doesn't tell me how they're connected to each other. because they're not like all even numbers. They leave some out. What's the deeper connection between these? The very surface connection between all of these. And this, again, this kind of captures what Kurt said, or what, I can't remember now. Charles, I think you're the one that said, add it plus 1. What's 2 to the 0th power? What's 2 to the 0 power?
1.
What's 2 to the 1st power?
2.
What's 2 squared?
4.
What's 2 cubed?
8.
What's 2 to the 4th power?
16.
Oh shit! So then we're not working with this. We're working with this one. So this is like, so what would a n be then for this? It would be 2 to the n minus 1. Is that cool? But that's not the sequence I've got. My sequence takes all of these minus 1. Do you see that? So sometimes the sequence you're given, if you added or subtracted a number from all of them, it becomes a relatively easy sequence. Well, then that would mean you figure out the easy sequence and then you adjust it to become the freaky ass sequence. Maybe? Does that? So part of sequence writing general formulas for sequences is understanding what to even look for. Right? When you kind of make sense. You guys with the 147, you guys were on it because you know you can look for adding the same number. Did you know you can look for this shit? Maybe not. Now you do. So if you're given a sequence and you're really like, I have no freaking idea, maybe think, are they 1 away from something nice? 1 up, 1 down, 2 away, 3 away? No, yes, maybe, no, sucks. Sort of. Okay. All right. So let's do some the other way around. Oh, let me talk about Fibonacci. Have I never brought Fibonacci up before? Must be another class I did that in. Anybody know the Fibonacci? See, at least one person does, I believe. Starts with 1, 1. No, okay, so don't say anything. If you know the Fibonacci, keep it to yourself. So let me write down the Fibonacci sequence. I'm not going to write down all of it because that would take the rest of my life. Okay. And then I would die and I wouldn't be done. Can you see what the pattern is here? Especially if you've never seen it before. If you've seen it before and you know, just kind of keep it to yourself. You don't have to start at 0 now. 2 plus 1. Okay, that's not really telling me what the pattern is. So yeah, sure. 2 plus 1 is 3. And the number that came before. Add the number that came before. Okay, let's see. That sort of sounded like part of an epic poem. I thought that said and the number that came before. Yeah, so A1 is 1, A2 is 1, A3 is A1 plus A2, correct? What's A4? Written like this, what's A4? Yeah. What's A4 written like this? Yeah, there we go. I'm sorry. A2 plus A3. So that's going to be 2 plus 3. I'm sorry. 1 plus 2 is 3. There you go, Jeff. Look at you go. A5 is going to be A3 plus A4, which is 2 plus 3 is 5. That's amazing. So what is AN? Going to be A5 is A3 plus A4. A4 is A2 plus A3. How does this always relate? You guess what's the connection? What would AN be? What is this one always? It's always, how is it related to what I want? This one.
-2.
It's always 2 less, so it'll be the term 2 before. So to get to this one, it's the term 2 before it plus the term 1 before it, correct? Isn't that what this is? So the term 2 before the one I want plus the term 1 before the one I want. That is not good, but that does capture the idea. Why is this not good? Because could you figure out the 711th term easily? Could you figure it out? Yeah? Yeah? What do you, okay. And this is not using Google, right? You could just figure it out. Are you sure? What would A711 be? It would be A709 plus A710. Do you know what A709 is? No. Do you know what A710 is? No, I have no freaking idea. So this is called a recursive definition. Jeff, you can make a, there you go, buddy. There you go. Recursive definition, recursive. Recursive is sort of like, it means it comes back on itself. So it builds off of itself, which is actually what the Fibonacci sequence is based on, and is why it shows up in nature, because nature builds on itself. So if you see Fibonacci sequence in nature, you see it in music, you see it in art, you see it in the stock market, believe it or not. Okay. Weird shit. So it's called a recursive formula, recursive definition for a sequence. It is not the best because, like I said, you can't use it to immediately figure out anything, but you can use it to write out as far as you want to. So it's not completely useless, but it's useless adjacent. Okay. All right. I'm going to erase all this. You ready? Oh, and trust me, if I wasn't careful, I could go off. I could have a whole semester or a year to study Fibonacci sequence. It's a little insane. Try to Google search Fibonacci music. Try to Google search Fibonacci stock market. Try to Google search Fibonacci art. Fibonacci surfboard. Believe it or not, there's anyway. All right. Where's it going next? I forgot. Shit. Oh yeah, that's right. Okay. So what about this? Let's talk about, since we just did recursive, let's do an example going the other way around. What if I said AN equals 2AN minus 1 plus AN minus 2. So it's a little bit like Fibonacci, but not quite. Now notice something. Did somebody notice in the Fibonacci how many numbers I had to give you before I can start to generate it? Fibonacci, I've got to give you the first 2, and then you can go 1 plus 1 is 2, and 1 plus 2 is 3. Somebody pointed out you could start at 0. That would still work, but that's not the formulation I like, so too bad. These are called the seeds. Oh, yeah. Oh, yeah. That sounds weird. Sounds like I'm going to start to do a whole religion thing. You got to lay the seeds and let the math grow. No, screw that shit. They're just called seeds. What do you want? So how many seeds do I need for this? What is the term based on? It's based on
2 seeds.
2 seeds. I need 2 because one term is based on the 2 that came before it. So let me say A1 is 4 and A2 is 1. Can you figure out for me what A3, A4, and A5 are? Go. Do it. So if you're really careful, so like if you really want to be careful, can somebody tell me what is n for this one? What is n? To figure this out, what's n?
3.
N is 3, correct? So then I can just write twice a sub 3 minus 1 is 2, plus a sub 3 minus 2 is 1. And now I can fill in what I know. Right? So really, sequences are like functions. This is almost like f of n, but there's special functions where the inputs are in order of the elements as they come. So this is natural numbers, but it really is just like a function. You throw a 3 in for n, then you throw a 4 in for n, and so forth. So this becomes relatively simple. Go ahead and finish it out if you haven't gotten too far yet. All right, let's see. So here I'm going to do twice a2 plus a1. So that's 6 now. So that's what a3 is. So now here I need twice a3 plus a2. That's 9. Jeff, try again. $14. And then, so now I know what a4 is. So twice a4 plus a3, which again was 6. So that's 32. Did you get that one right, Jeff? I think so. So let's see what we got. We got 4, 1, 6, 13, 32. Neato. Funkadelic. Okay. That's kind of neat, right? You don't even know. Oh my God, you don't even know. In fact, it was only 10 years ago that I learned some higher level shit about this that just blew my mind away and kind of took over my life for a little while. And I never quite finished it into a point where I could do like a presentation on it or something. And I wish I need to go back to it and bring it back.
I have a question.
Yes.
Can you figure out the formula by looking at the numbers?
Oh,
This case?
recursive formulas like this.
Yeah.
You could, if somebody told you this, well, even if nobody told you it was recursive, that would be something you would try now that you know they exist.
Yeah.
You know what I mean? So like here, it starts 4, it goes down, and then it goes up. So it sort of seems like it's not adding the same thing. I'm not multiplying by the same thing, right?
Yeah.
So then if you kind of give up on a direct thing, you might think, well, is this recursive? And then you start trying to formulate possible recursive. Yeah, it's not impossible. It's not nearly as easy as what we're doing a minute ago.
Yeah.
But totally real, of course. Yeah.
Thank you.
Sure. So again, it's just knowing it's a possibility. So you have one more thing to try. That's a huge, I don't know if you picked up on this, but this has happened a couple times in this class. Pre-calculus is all about that. Here's something you've never seen before. Now you know it can happen. It's one more thing to try in the future. Hey, here's something else you didn't know. Something else that could happen. Something else to try in the future, right? Same thing happens here. I love it. All right. All right, let me erase all this. Okay, so let me see, what else do I want to do right now? Yeah, let's do that. I've got a, oh, I haven't put it up there yet. That's not good, Jeff. I've got a handout for this. that kind of goes over the first and last section in chapter 13. I don't think I even, no, I didn't. Of course not, Jeff. Why would you? I haven't put it up on Canvas yet. So you will give me a moment because I want you to. And I'm the teacher. Let me see. Here we go. Kapop. There we go. No, I don't want that. Okay. And let me throw it up here. Larv. Oh, I need to make a module. Shit. All right, guys. Unit 13. That's fine. Bam. All right, so this is going to be a little handout that kind of covers what we talked about already. I don't think I have recursive on this. No, I don't have recursive on this for whatever reason. It covers 13.1, which is what we've been talking about. And then it covers 13.4, which is kind of like the next level, believe it or not, because 13.2, now listen to me. 13.2 is, I think, arithmetic sequences, and 13.3, I believe, is sequences based on multiplication, and those are called geometric sequences. I'm probably not going to make you do the homework for, in fact, if I'm going to say this, I have to say I'm not going to. I'm going to make the homework for 13.2 and 13.3 extra credit. Does anyone have a problem with that? Okay. I didn't think so. You never know, though. So let me put this up here. Sorry. Hold on. All right. If you go to Canvas, is this going to work? Oh, yeah, I guess so. All right. I just did something in a weird way that all right. If you go to Canvas right now, there's a unit 13 up there now in the modules. Let me show it to you. Let me become a student. Then you come down, unit 13 sequences. You got this little handout here. So let me open this up in a better way. Oh shit. There we go. Bum, bum, bum. There it is. Oh no. Dadgummit, it's on the wrong monitor. Hold on. Okay, here we go. There it is. All right, guys. So what I want you to do, go ahead and do. Oh, is this the same one I did before? Dadgummit. Oh, well, here's a more interesting one. So do these 6 problems. The first 3 should be very quick. This one will definitely be quick. Well, good job, Jeff. This one should be quick. This one should be a little more challenging. So try to do those 6 problems. I'll sit here and somehow still make money. Well, I just do nothing and watch it. All right. I don't want this. Okay, it's fine. Oh shit. There we go. Okay. All right. Whoa. So guys, you got it. Please tell me the first few are not bad at all, right? Let's see. I'm gonna kind of catch up to you guys. So the first 4 terms. So this is now A1 would be 1 over 1. A2 would be 1 over 2. A3 would be 1 over 3. A4 would be 1 over 4. Yay! That's pretty easy. And again, just to make sure somebody's maybe not getting it and not speaking up. When I want A1, I'm saying that n equals 1. So then I just put a 1 where n is. When I want A2, I'm saying that n is 2. So then I just put a 2 where n is. So that's what I mean by it's like a function. Okay, so here, same thing. So by the way, n does start at 1 and go to infinity unless they state otherwise. So you could have problems, especially if you're going to go to, anybody supposed to go to calculus 2? Is anybody supposed to take up to calc 2 at least? All right, calculus 2, you do a deep ass dive into this stuff. Yeah, I love it. I love it. And normally students don't like it as much. And that's, you know, but anyway, it's some awesome shit. So this one again, if I want A1, I'm just going to make N1 and put a 1 there and there. So you get 1 over 4. Is that cool? I don't know why I'm being all formal in this one. A2 would be 2 over 5. A3 would be 3 over 6, which is 1/2. And A4 would be 4 over 7. Too nice, too easy. So if they give you AN and they ask you to come up with the first 5 terms, you go, oh, thank God, it's just plugging shit in. Very difficult to make a hard one of those, right? Then along comes C. So let's see, let's be more careful here. A1 is 1 plus negative 1/2. Oops, somebody's talking to me. Let me see. Sort of statisticky. Just, do you mean because of this symbol down here that we haven't gotten to yet? In that case, I would agree with you. That's a symbol that we use in statistics. Let's see. So this will just be 1/2. Patterns, sure, yeah. But you know, most of math is somehow based on patterns. 1/2. A2 will be 1 plus negative 1/2 squared. So here's something interesting. I want you guys, do you understand what's happening? This is a very interesting problem. All the odd powers, all the odd ends will make this be subtraction, and all the even ends will kill this negative and make it addition. So do you see how it's kind of like oscillating around 1? Does that make sense to anybody understand what I'm saying? So this would be 1 plus 1/4, 5/4. A3 will be 1 plus negative 1/2 to the 3rd, which is 1 minus 1/8, which is 7/8. And then A4 will be 1 plus negative 1/2 to the 4th, which is 1 plus 1/16, which is 17/16. Oh my goodness, I'm way down there. Again, if you're careful with plugging it in and not going too quickly, it's not a problem. It's pretty simple. You just plug 1 in for n, plug 2 in for n, plug 3 in for n, blah, blah, blah. Okay, maybe. All right, we already did part A. I think my thing I did wasn't exactly this, But did anyone get to part B yet? My sequence wasn't exactly this, but it was pretty close to this. I'll take that as a no. We already did 2A. All right, so do 2B right now if you haven't done it yet. Does anyone have an answer to part B yet?
Yes.
All right, hold on, Rio. I know you get this idea. Does anyone else have a possible answer for part B? I don't understand. So that's, all right. They can't be the answer because they're not all 3/4. I need some function of n that will generate each of those numbers forever, right? So I'm sorry, we've taken a turn. Like number 2 is not like number 1. Number 2 is the opposite of number 1. So I want to know, what is this generating function for this? So we did one a lot like that one about 11 minutes ago, roughly. Now I want to check the video afterwards and see how close I was. All right, so now I got another chat. Oh. Well, the answer after 6 7 should be 7 8, right? Isabel?
Is it 1 plus 2 over 1 plus 3?
All right, so let's do this.
Oh,
So I agree with you. A1 is 1 plus 2 over 1 plus 3. That is true.
and then the next one would be 2 times 1 plus 2 over 2 times 1 plus 3.
Yeah, let me get rid of this here real quick. Gather. So this is good. This is exactly what you have to do to kind of piece it out. This will be 2 times 1 plus 2 over 2 times 1 plus 3. So you see how we've identified. So this is 1 times 1, 2 times 1. And we could have actually been, anyway, it's okay. So then what's AN? Do you see how the 2 and the 3 are going to be sitting there waiting, right? So A1 is 1 plus 2 over 1 plus 3. A2 is 2 plus 2 over 2 plus 3. So what's AN?
1 times n.
Yeah, n plus 2 over n plus 3. Yeah. You don't even need it times 1, right? Because times 1 just leaves it the same. Do you guys, all right, I'm not asking you if you're comfortable. I'm asking you, are you starting to see how to attack these problems, right? Like Charles is like, left. I have to be careful. I don't want to make it sound like I'm asking you if you're comfortable. Of course you're not comfortable. If you never worked with this shit before, it's remarkably uncomfortable. But this is exactly what I did. This is exactly what you should do to start to piece this together. Now, what about part C? Part C is interesting. Part C is related to a problem we just did a little while ago. Do you see how the tops and the bottoms are related? What's the relationship between the top and the bottom in each one of these fractions? How's the top related to the bottom in each fraction? Guys, come on. Yeah, the bottom is one more than the top, or the top is one less than the bottom. Right? So if we look at the bottom looks like it's going to be an easier expression. What do I keep? What here's the first one is 2, the second one is 4. So A1. This is a 2 on the bottom. A2, this is a 4 on the bottom. Right? A3, it's an 8 on the bottom. So what's the connection there?
To the nth power.
2 to the nth. They just keep multiplying by 2. So this is 2 to the first times another 2 times another 2. And we already said the connection between the top and the bottom. Whatever the bottom is, the top is 1 less. Yeah. That's what it is right there. 2 to the n minus 1 over 2 to the n. In fact, let me push this a little bit more. Do you guys see how this is not exactly the same, but it's kind of close to this? All right, maybe I don't want to go too far with that. I just want to point that out. And in case you want to look at it, you can see how there's a 2 to the n right there. Anyway, so there's a connection between those two. I don't want to get too deep into it. All right, let's see what time we got. Yeah, let's call it a night. I'm all about taking this last week simple. So what we're going to do, so just to remind you guys what I just said earlier, 13.2 and 13.3 will be extra credit. You don't have to do it unless you want to. The way I apply extra credit homework is directly to the homework grade. So if you have 100 homework grade, I'll still add it on top of that. So you'll end up with above 100 homework grade if you do all the homework and extra credit. If you don't have 100 homework grade, they'll get closer to 100 homework grade. It's crazy. We are going to do 13.1. We are going to do 13.4. Yeah, 11.7 is also extra credit. I think there's at least that other section that I made extra credit. I think, right? Isn't 11.7? I'm pretty sure that's the other one. Anyway, all right, guys. That is enough for tonight. Come ready tomorrow with your chapter 12 questions, maybe. And then we'll finish up chapter 13 and we'll see if there's any time tomorrow to get into the practice final. And let me check. Is 11.7? Yeah, 11.7 is extra credit. Yeah. Bye. How do I do corrections? Do you mean homework corrections?
Thank you.
Sure.
Goodbye.
You guys, homework corrections, you just do any that you got. Oh, midterm correction. All right, you just, on another sheet of paper, you just redo any that you lost points for, and then scan that and submit it in the same place that you turned your midterm in. Yeah, you might want to print out a copy of the midterm with the feedback, because once you submit your corrections, you won't be able to access earlier things you submitted, like the midterm itself. Okay. How's everybody else? What's up? You guys okay? What's going on?
I wanted to talk about the quiz 2 correction.
Quiz 2?
Yeah.
All right, what's up?